Hey guys, so today I want to talk about the chain rules. So, when do we use it? When is it appropriate to use it? When do we not use it? So, we use it when we're dealing with composition functions. Anything that's kind of wedged into each other, like this formula right here. If I were to expand it, it would look like f prime. That little stick thing I made is called prime, and that means you change whatever is right before it. So that F would change. So then I have a G that follows after. And then I multiply the prime of G. And there's a little tiny arrow here for visual. This arrow right here is actually the chain part of the chain rule. What's interesting is a lot of the modern textbooks don't show this arrow, but the older ones do. And once I discovered this arrow, it really helped me. So I'm going to use it throughout this video. So I'm going to show some examples of the chain rule and when not to use it. So here's two problems. Which one do you suspect is the chain rule? Which one is the composition function is what we're really asking, right, about the chain rule. Which one is a composition function? Which one's kind of like layered into each other? So the answer is actually the first one. This is going to follow the chain rule. The second problem set is not. So let's work on both so you can see what I mean by that. I'm going to work on these problems with the idea that you have some understanding of derivatives. So we're going to go ahead and take that 2 on the second problem and move it to the front, and then follow the n minus 1 rule. So we're going to do 2x 2 minus 1 plus 1 is a constant, so that becomes 0. So 2x 2 minus 1 is 1. And this is pretty much the final answer, but just to clean it up, it's just going to be 2x. And that is the answer. Now let's go to the one where it's going to be a chain rule. So the first rule with the square root is we get rid of it by putting everything into the parentheses and doing half for the nth degree, right? So anytime you have a square root, it's always going to equal parentheses positive half, just to let you know about that. So now this is just the setup, okay? We haven't actually done any of the math part yet. So now the second stage is math. I'm going to take this half, I'm going to move it to the front, and then I'm going to follow the n minus 1 rule. So we have half x squared plus 1. Keep in mind the center stayed the same. And then half minus 1. Just to kind of speed it up, it's going to be negative half. And you can pause the video and kind of see how that works out and why that is. So I have this set up. Now, this right here is G. I'm going to put the arrow in and I'm going to work on the inside now. The outside is done. So I'm going to bring this 2 down. I have 2x plus 0. This is what I have going on right now. I'm going to clean it up. So I have half x minus, no, it's x to the second plus 1 to the negative half times 2x. Now maybe your instructor is okay with this as the final answer, but we can simplify further. We're going to take the half and the 2x and we're going to combine them. So in case you don't know, it equals 1, but let's go ahead and work it out. Half right here. Always put that invisible 1 in the bottom of a whole number when you're multiplying against a fraction. So 1 times 2 is 2x. 2 times 1 is 2. 2 and 2 make 1. And we're going to keep that x. That x hangs around. So it looks like we're going to put an x in the front. And then we're going to do 2x plus 1 to the negative half. This can also technically be the answer, but we can further simplify it. We know that the negative half can make a fraction. So now we're going to end up with x over 1 times 1 over everything in that parentheses we had, x squared plus 1, and we're going to square root that whole guy. Again, this can technically be the answer as well, but of course we can further simplify it because, nothing's easy. We're going to put the x on top. All I did is just combine these two, just multiply them together. That's all I did. And now we're going to multiply these guys together, which makes square root of x to the second power plus 1. This is the answer. I know it feels like a lot of steps, but believe me, once you start doing this more and more, it's going to be very easy. I just showed every single step possible. A lot of that stuff you can most likely do in your mind. Let's look at some more problems. Here's some trig stuff. So we have sine x and then we have sine 6x. Which one do you suspect might follow a chain rule and which one might not? Look really carefully. So anytime you start doing your homework or you get a printout of some type from your instructor, always go ahead and put the parentheses in. You want to start getting in the habit of doing that. So there's a parenthesis here and there's a parenthesis here. You'll be surprised how many times they don't show you that in the material that you're supposed to be studying. So go ahead and just do that for yourself. I don't know if it looks a little bit easier, but you can see now that the chain rule would actually apply to the second problem set. So let's go ahead and do the first one. So sine x is cosine x. So this answer is going to be cosine x. That's the answer. Pretty straightforward, pretty quick. What about this guy? It's a little bit different. So we're going to follow the same rule of f and g, right? Where we change f first and then we change g second. Put that prime there. So we'll follow that method. So here's f, here is g. F, g. So we're going to change f first. So sine is cosine, but we keep the middle part, the parentheses, the same. And this whole thing is f. Now, what I'm going to do is I'm going to use the arrow. I'm going to put that little line with the arrow here, and I'm going to now do the derivative of g, the inside, which is 6, and x becomes 1. So without the arrow, it looks like this. Cosine 6x, 6. Now this can technically be the answer, but typically we move the constant to the very front. So it's cosine 6x. Both of these are the exact same thing, but this is the answer I'm going to select. What about this one? So I have a linear, I have a quadratic. Which one do you suspect, if you look very carefully, which one do you think might follow a chain rule? Which one do you suspect might not follow the chain rule? We're basically looking for layers. A good hint is if there's some parentheses in there, it's most likely going to be a chain rule. So it's going to be the second one. And let's go ahead and do the first one. Let's do one term at a time, just to take it slow. So we keep the 3, and the x becomes a 1, and then the 2 becomes a 0. So I have a 3 right here. That's the answer. Now let's look at the second term. Second problem. I'm going to take the 5, move it all the way to the front, So I have 5, keeping the inside the same, 3x plus 2. And then 5 and minus 1 is 5 minus 1 equals 4. I'm going to make it that a 4 right there. This is what we're going to change next, because we already changed the outside. We're changing the inside now. We're going to have 3, 1 plus 0, because 2 is a constant. If I were to clean that up, it would look like this. 5, 3x plus 2 to the 4th power times 3. This could technically be the answer, but we could further simplify it, so we can multiply the 3 and the 5 together, and that gives us 15. So I have 15 that I move to the front. It could technically stay in the back as well. And I have 3x plus 2 to the 4th power. And this is my answer right here. I hope these are making sense. Let's do one more. We have these two problem sets. These look a little bit tricky, right? So let's try our best to put the parentheses in like we discussed earlier. Parenthesis there, parentheses here. And we could put a parentheses up here as well. So what do you suppose? Which one do you think is going to follow the chain rule, and which one do you think will not follow the chain rule? This one's a little bit tricky, because it's pretty intimidating. It's actually going to be this one right here. This one is going to follow the chain rule. The reason being is there's a little 2 right here, and there's a little 5 right there. So when there's extra stuff added into just like the basic template of what you typically see, it's an indicator that this is becoming a composition function. And maybe that statement didn't make sense, but once you start doing like homework problems, you'll start seeing that. You'll start seeing that these problems look like extra long, extra kind of like cluttered almost. That's also kind of an indicator. So let's go ahead and start on the one that will not be the chain rule following. So one term at a time. E to the x, its derivative is going to still be e to the x. This is a unique example where it's always going to stay the same. Then we do the plus sign. Always keep that plus sign, right? If you don't, it can change up the answer completely because you might think you're multiplying. So the derivative of tan is secant square. Secant square. And this is the answer right here. Now maybe you're looking at this too and going, well, what if I did secant x square? Would it still be the same? And the answer is yes, absolutely, 100%. These are both literally the same exact thing. This placement of the 2 it has no value. It does not matter. You can keep it right before the x or right after the x. It makes no difference. Both are correct. So let's go ahead and try with the chain rule. So you want to take it slow when you're doing the chain rule. So I have e to the 5x. We're going to do the chain rule of this nth degree. So it becomes 5, 1. Which means it becomes 5e to the 5x power. That's the first term. That's the whole full first term, right? So now let's do the second one. Don't forget that plus sign. See, with this example, you want to put the plus sign because you'll see why. So, of course, I take the 2. Even if the 2 was here, I'm still just going to take the 2 and move it to the front, okay? So, let's see. I'm going to take the 2, despite where it is, and move it all the way to the front. So now I have 2 up here, and I'm going to go ahead and keep it to tan x 1. I'm going to take the tan, and I'm going to turn it into secant square x. And that little 2 can go anywhere. It's not significant. So we're going to do 2 tan x times secant square x. Now this is my answer. If I did not put that plus sign right here and I forgot about it, I would have accidentally taken this 2 and this 5 and multiplied it, made it into 10. And then it would have been 10e 5 to the x tan x secant square x, which would have been absolutely incorrect because we aren't multiplying, we're adding. That's why it's very important to pay attention to the operator or like the plus and minus sign, because with these problems, you have to take the constant, the numbers that are just dangling by themselves, and combine them together if it's multiplication. So it's very important that you stay focused on the signs and take these very, very slowly. You might be able to do the math quickly in your head, but that doesn't certainly mean that it's going to translate on paper. So take these problems very slowly. I hope these chain rule examples helped you. All right, guys, take care. Bye.